Thank you everyone for coming today and yesterday as well if you came. Really looking forward to today's discussion. Sitting here with Evan and Connor, and we're going to talk about robots and the future of augmenting human life. So I'm actually paralyzed, and that's why I think this conversation's really fitting, because a lot of the robotics we're going to be talking about today are going to be something that might augment my life in the future. And so it's something really interesting to me. I run marketing for SkyFi, the group that's putting this on. Thanks Luke and Kate and the team at SkyFi for putting this together. Lots of people here to make this thing run. I'm really excited for this conversation. So kick it over to Evan to start us off with just a little introduction. We'll get going.
Sounds good. Thanks, Tom. Thank you so much for having me too, and thank you to the organizers of Austin for America. This is so cool. I'm actually from Austin, so it's really nice to be home and not have to explain what a breakfast taco is anymore. My path to the stage probably starts with my previous employment at Apple, where I worked on on-device intelligence and privacy features for Apple Intelligence for a number of years before co-founding Weave Robotics with my best friend in the world. He's also ex-Apple, and sometime in 2024, when we realized that the necessary tech to make a practical, general-purpose home robot was coming online, but that nobody was actually building for consumers. Nobody was building for the home and for people. We thought that that was wrong. We knew how to build it, and so we left our jobs at Apple. We got into Y Combinator, launched to the public in September of last year, and promptly sold out of our first reservations of our product. And we're now a team of 10 building in San Francisco. So what are we building? Why am I here? We're building a general purpose home robot called Isaac, and we're shipping to our first customers later this year. It'll autonomously fold your laundry, tidy up messes on floors and surfaces, and be a remote caretaker for you, whether you're at home or away. And I think that we make hopefully a good addition to this conversation, because we've tried to distill this seemingly futuristic technology down to its bare essence so that we can ship it and solve practical problems for people as quickly as possible and empower you, the owner, the consumer, no matter who you are or where you're at in your life. And I think that makes me really excited to share the stage with Connor, because I think that their vision at Phantom Neuro is aligned.
Thank you. Hey guys, I'm Connor. Thank you so much for being here. It's really an honor to be able to talk to you all at this event. I'm actually a medical doctor by training. I have a really strange obsession with function-limiting injuries and ways that you can incorporate robotics into kind of the sphere of things in order to give people their lives back, whether that's by giving people robotic limbs to replace their missing limbs, or allowing people to utilize exoskeletons to augment whatever function they have left, or allowing people to remotely control different machines around them wirelessly. That's kind of my obsession. And I started off really approaching this from the medical perspective, and ultimately the plastic and reconstructive perspective, thinking that all the technology associated with this human-machine integration had already been figured out. I'd seen incredible demonstrations of people controlling, individuals with disabilities, controlling these different robotic systems like arms and legs and exoskeletons as if they're parts of their body. And I thought, this is absolutely incredible. So I was under the impression that I could go be a reconstructive surgeon that makes basically cyborg humans and gives people their lives back, and that would be the most incredible career I could ever imagine. So after medical school, went to Johns Hopkins, did a research fellowship in reconstructive surgery, focused on microsurgery of the limbs and nerves and muscles and bones. And once I got into academia and the research of all this, I quickly realized that the technology, aside from the robotics, that the technology did not exist, and that there was nothing to be able to translate these really amazing results that we see on YouTube and 60 Minutes and so on and so forth that are occurring in the lab, to translate that out to a real world environment so that your average person that has one of these types of injuries can have that kind of a benefit in their lives. And really the crux of it was the human-machine interface. How do you take intention from the human body, electrical activity, among other things, and translate that out into a robot so that the robot functions like a natural extension of the human body? And most people are familiar with brain-computer interface like Neuralink and what Elon's working on, but that's an incredibly invasive way to go about that, and it's actually not necessary in the vast majority of cases. And so at Phantom Neuro, the technology that we ultimately came up with was a minimally invasive implant that goes in your limbs, under your skin, So it can go in your amputation stump or your weakened limb or whatever it might be, and it records the electrical activity from your muscles instead of from your brain, and does the exact same thing. We decode that electrical activity, and then we tell a robot what to do in real time. So a person thinks about closing their fist, and then the robotic hand closes its fist immediately based off of the person actually trying to do that. And so we're trying to develop technology that balances safety and efficacy in the right way so that as many people can benefit from this as possible. And there's so many synergies with like what Evan's working on within the robotic space, and we're all at the end of the day trying to deploy machines in a really effective way to be able to help people get their lives back or maybe even surpass where they were before some kind of injury.
Yeah, really cool. So I actually was at Neuralink a couple weeks ago touring the facility and was really amazed to see kind of where they're at today and what's going on with this technology. And so when I met with these two guys to kind of figure out what we wanted to talk about, one of the rules we set was we didn't want to create speculation and kind of talk about what the future could be, because there's a lot of conversations that are kind of just not true about what that is. So I guess my first question here is like, what are you working on right now in the facility? Like, what did you do yesterday or last week, and what are you gonna do tomorrow and next week? And where are we at today? I'll start with you, Evan.
What we're doing right now is all the different things required to build this vertically integrated product. So we collect our own data with which to train our robotic manipulation policies. We order some parts off the shelf, but we increasingly design more and more of our sub-assemblies in-house because that's the fastest way to move. We're testing these on those use cases, folding laundry, picking up toys off the ground so parents don't have to step on Legos anymore, and having it autonomously navigate around our office. And to echo what both of you have been saying, it's central to the bet at Weave that you can actually bring the future in by focusing on core practical problems rather than overcomplicating things beyond what's essential to deliver for the problems that people actually have. So we're trying to keep our focus on that, and that's the way that we're going to ship this year in 2025.
Which is incredible, by the way, that in 1 year they went from like concept to shipping product in a hard field, which is just mind-blowing. So at Phantom Neuro, we're starting with upper limb amputation and allowing upper limb amputees to control robotic hands, wrists, and elbows. And so we've been hard at work developing that product, and we're actually implanting humans for the first time this year, which is going to be incredibly exciting. And so we'll implant multiple upper limb amputees and have them control other people's robots. Again, because the robotics side of things is quite well developed. It's the human-machine connection there. And so we really focus on problems that we can solve in the here and now, and talking about problems that we can solve in the here and now, and trying to keep the conversation focused on reality today rather than all the speculation of what might be in the future and some of the scarier scenarios that can occur and all of that. The reality is that there's so much exciting stuff that can happen right now that we're all actually deploying and making happen. So it's pretty incredible.
What's your team made up of? I'm just curious. Like, is it software developers, hardware?
My team is pretty much all engineers. So I have no technical background, also no business background going into this. And so I had a concept for what we wanted to build, and then really had to bring people much smarter than myself around me to go from concept to building out something. So we've got about 15 employees at this point, almost all of which are engineers working diligently to ship this product.
Yeah. What about you, Evan? Are you guys working on partnerships? Like, there's got to be a software component, right? And then hardware as well?
Yeah, we are entirely focused on building right now. Every single person that we've hired to get up to our team of 10 has been a firmware engineer or a mechanical engineer or a machine learning research engineer, data engineering. We know that the right way to win and to enter this really, really important product category is going to be to build and realize what the bet that we made sooner. I also do want to tout you got some good news from the FDA this week. So you've also been putting in the hours probably before this, but that's something else cool that's happening right now.
We basically told each other we're just going to hype each other up this entire time. But yeah, we have been working really hard and got some great news from the FDA. We got this designation called Breakthrough Technology Designation that really demonstrates It really focuses on technologies that can be a monumental stepwise improvement in the quality of life of patients rather than like a next best iteration of something that already exists. And so it allows us to work closer with the FDA and really expedite our core product to market. Thank
I
you.
agree.
Thank you so much.
Very cool.
Appreciate it, guys.
I'm curious, is AI playing a role in what you're doing? Like, are we to a point where AI can help?
Yeah, so AI plays a critical core function in what we're developing, but we have to approach it from a unique way. So obviously, we extract all this data from the human body, electrical data and movement data. And you have to decode that data in real time into some useful control output to control a robotic arm or whatever it might be. And so that requires artificial intelligence to decode those signals on the edge at the person's house or home or wherever it might be, and to drive that action in the person's life. But something interesting that we have to worry about is that latency of our system is everything. So we all know if you type something into Google or ChatGPT and it takes 30 seconds or something to spit out a response, that's very frustrating. Well, it's even more frustrating if you're trying to control your limb and you're waiting 30 seconds for something to actually happen. That's a useless product. And so we have actually a target goal of 300 milliseconds or less, which is very fast, to go from detecting a signal in the body and actually outputting some useful control to a prosthesis. And so we have to build very lean artificial intelligence architectures that are also extremely low power so that people don't have to wear like massive battery packs to control their prosthesis plus our system. And so there are unique aspects to what we're developing that constrain our ability to get really creative and fancy, I guess, with artificial intelligence. And so we do some novel but yet really straightforward things to allow our system to be really accurate and incredibly fast and incredibly low power.
Is there a future where I can control something across the room?
Absolutely. So you can definitely control something across the room, theoretically, even with the system as it exists today. But then there's like security concerns that come into if you have like this wireless sphere around you that extends out to an entire room's radius, then there are these considerations that you have to overcome. And so we try to keep somebody's wireless signature, I guess, to, within a meter of the person's distance to make it more secure and more reliable, right? Because when you communicate utilizing Bluetooth or something like that, most Bluetooth systems actually start to significantly decline in performance when you're in a really large room with a whole bunch of other people utilizing Bluetooth at the same time. And so, anyways, there are unique considerations.
Okay, cool. What about you, Evan? Who controls Isaac?
The user ultimately controls Isaac. I think that the thing that we are building is something that is ultimately and hopefully an extension of you only. And I think that that makes this all the more germane for this conversation. So we think that a really, really good first product like this needs to have autonomous capability out of the gate. So you'll be able to have Isaac basically deploy into the background while you go and do other things and fold laundry or make sure that your living room isn't actually a landmine, or go and find your keys or figure out what's actually in your refrigerator so that you can know what you can actually cook for your family that night. We'll also ship it with teleoperation, which is the ability to have somebody who Weave employs remotely control your Isaac with your consent so that it can do other things that it's embodied to, but that we're not planning to ship with autonomous capability for out of the gate. So it'll always be acting as an extension of your intent.
What does that look like when someone else is controlling it? Is it someone in your office, or are they across the world, or what does that look like?
Yeah, when we first ship, we intend for these to be people with whom we're co-located so that we can own the process from beginning to end. But there'll be people who are employed by us who you consent to have operate the robot within your home to do a variety of things that may come to your mind. And that's actually a key part of why it's important that Isaac be a general purpose robot from the beginning. Isaac is going to look like Rosie from the Jetsons. It's a bimanual robot with a wheeled base, a human level of height. And that matters because while we're focusing on a couple core use cases at first, we want it to be embodied to graduate to ever more capability over time. And that's why the general purpose form factor is an essential part of what we're building, even if we're also distilling it down to its very bare essence.
Okay, this is a question for both of you, but like with Neuralink, I don't want to get V1 because I want it to evolve over time. So is V1 of your products going to be able to evolve, or do I have to buy V5 again? Does that make sense? Connor?
Yeah, I can go first. So we've actually significantly over-engineered V1 of our product so that we can learn as much as possible with V1 and incorporate as much ongoing utility to the system as possible. And so similar to like if you imagine Tesla, right? You can do a software download or a firmware change, and you can get like a radically different functionality out of the car, or different performance, or whatever it might be. So our implants actually can be over the air, updated in very secure ways, as the FDA allows, and you can get different performances and use cases for the system utilizing the same implant but changing the firmware that's on board and on the outside. And so a person can have an implant for 10 years or whatever the lifetime might be of the implant and get radically different performance over time. And I think what we'll also find is as we learn more with our initial system, we'll probably be able to cut back on some of the functionality so that you never want to over-engineer, because that means you're utilizing more power than you have to, or you're implanting, for us, more hardware than you have to. And so I'm hoping that, and I believe that our technology will get smaller, better, faster, stronger over time, but this first one is a beast of a machine.
In our case, this actually goes back to what I was just saying. Part of the reason that we want it to be general purpose from the beginning is because we actually intend for it to last people for years. We want Isaac to not be held back by its morphology, by its form, when we train ever more sophisticated models to power its autonomous features. So it needs to have the arms, it needs to have the human level of height and reach with which to like make the best use of that. So we're designing from the beginning with that in mind, and we're designing with premium parts so that it does last our customers for years, especially the people who are our first reservation holders and believe in us and share our vision of personal home robots.
Interesting. All right, I'm going to change the topic a little bit. So ChatGPT came out like 2 years ago, and I can't live without it now, right? It's awesome. You guys probably agree in the crowd. What is the point with robotics where we can't live without it anymore? And what do we need to get there? We can start with you, Evan.
Yeah, I think that this is up to the builders, but I think that if you have chosen the right use cases and if you have built a good product, it ought to be right from the get-go. If you've taken a ride in a Waymo, I'll bet that most people who've done it see that that's the way that it's going to be in the future and are kind of excited about that. I think that we, after talking to dozens of people, hundreds of people maybe even, about what our first use cases ought to be, we know that these are problems that are acutely felt, even by people who can already afford to have help in their home. Truly well-crafted, embodied, intelligent products are going to solve problems, and it's going to feel like the way it always should have been from the beginning if you've done your part.
Go ahead, Connor.
I think we're fortunate in our business and that it's pretty obvious what the problem is that we're trying to solve. So you see somebody who's lost their limb, like that is obviously a very serious problem that everyone agrees that somebody needs a solution for that problem. And so somebody being able to have their limb back who otherwise had lost their limb, that's something that they cannot live without or really don't want to live without, really at all costs. And so I think like when people start to receive our systems and these different types of machines around them that can give them their lives back, especially in the setting of function-limiting injury where you're rebuilding to whatever has been lost, that's something that people will not want to go back
Absolutely.
to after experiencing kind of these technologies.
I almost forgot to drop a relevant statistic here that matters for the use cases that we've chosen at Weave. I looked this up over the summer. The Bureau of Labor Statistics estimates that the average American 15 years or older spends an hour and a half on average every day on housework, excluding childcare, which totals 3.5 years of an 80-year life for an American. And we live with some of the best standards of comfort in the world. I think that people are going to delight in having that time back. So I think that the moment will be as soon as you get one.
What's the plan for affordability? Like, it's really expensive. All this stuff's really expensive. And if you want mass adoption, it has to be somewhat reasonable. Is there a plan for that, or is it just like supply and demand? How does that work?
Yeah, I think that it's important to note that while we're building this first of its kind product, and it will be our first product, it's not going to be the last one that we ever make with Isaac. it's a common trend of adoption in technology that we've seen with other products like before, that successive generations not only get better, they also get cheaper. And so we expect that eventually we'll make a successor to Isaac that only advances on the cost, capability, safety, Pareto frontier, and that is much more accessibly mid-market priced, such that we can put this in millions of homes. And we already have interest from people beyond the United States too to tap into in terms of global demand. I'm sure that this is super top of mind for you though too.
Yeah, accessibility, cost, accessibility is everything, right? It's really hard to go to a payer, an insurance provider, Blue Cross, Blue Shield, or whatever, and be like, hey, we've got this awesome system. We just need you to, pay us $500,000 per system, and, everyone will be really happy. They're absolutely unwilling to do that. And so you have to reduce the cost of your system as much as possible. But within the medical field, especially within the medical implant field, the cost of your actual hardware and software and all that is only one of the factors that go into the cost of the overall system. There's the surgeon that has to put in the device. There's the operating theater that it has to be put within. There's general anesthesia. Sometimes that's a significant additional cost. There's the care after receiving the device. There's learning how to use the system over time with different types of therapists and otherwise. And so we've designed our system to be an outpatient procedure where you don't need general anesthesia, you don't need a specialized surgeon, and it's a quick walk in, walk out, 1 hour type of deal. And that's what allows it to be accessible to everybody all across the world. Yes, it's an implantable device with like precious metals and things. It will always be somewhat expensive. It's never going to be like $1,000. But we're talking like $10,000, $20,000, something like that. That's much more attainable and much more reasonable for payers to pay. When you're talking about something like a brain-computer interface, not to shit on brain-computer interface, but like you're talking about a formal neurosurgeon in a formal operating room with general anesthesia, a very specialized team, a lot of continued care after receiving that system, and all kinds of other considerations that drive the cost up to potentially hundreds of thousands of dollars per unit. And that's something that's incredibly hard to scale, regardless of how incredible and necessary the technology is. Unfortunately, we exist in a world where the finances really drive the decision making, especially in the healthcare system.
Yeah. There's a lot of skepticism about this, like a lot, as you both know probably. A lot of it's about stealing your job, right? We're seeing with AI, but robots as well. Do you think these things are going to steal jobs, augment humanity? Like, where are we at on that, and how long until we'll kind of get an answer? Evan, go ahead.
I do think that the answer depends on the vertical and it depends on the product. This is actually something that weighed on me and my co-founder quite a lot when we thought about what the best application for robotics would be. And I think that that's why we sleep pretty well at night building robots for consumers, for people. We want to give people time back that was otherwise forsaken to some of the most mundane things that we all have to do all of the time. And so we hope that we sidestep this question, because ultimately all we are trying to do is empower you to do even more than you would have before, regardless of who you are and regardless of where you're at in your life.
So we believe that utilizing our system, you basically will take somebody who is quote unquote disabled and make them super abled. And so basically what we're giving people is the ultimate universal controller. High bandwidth, high speed, high precision, universal controller. And so much of our world is interacting with machines around us, typing on a computer or driving a tractor or flying a drone or whatever it is. And that all requires control surfaces that have a very long learning curve and are very limited in how much you can interact with them, because you're limited to your 10 fingers and your hands. When you have this really high bandwidth, fast universal controller, you now get to break out of this paradigm of having to use your physical hands to interact with everything. And so I believe that people that receive our system, so like amputees to begin, are going to be the absolute best humanoid robot operators that maybe you will want to employ one day to be the remote operators of your system, because who's better to control a humanoid robot than an actual human, who controls robots with their daily lives and as their job. I also believe that, so I believe that like all these people with disabilities, quote unquote, will actually be like some of the highest functioning, highest paid, most successful people in society in the very near future. But also I believe that everything with this new artificial intelligence wave of the future, all of that's dependent upon data. And so with all of these systems, you're generating massive amounts of very high value data. and people should get paid for that data, their own data. I believe we should get paid for all the data that's being siphoned off of us at all times and being used against us. But I believe that utilizing like our system, people will be able to generate movement data that will be very valuable to humanoid robots and other human mimicking systems. And they can sell that data in order to make a profit off of it, harnessing this implantable system that's also giving them their lives back.
That's really trippy about people with disabilities making more money or being more productive. I said we weren't going to speculate, but I'm curious, what do you think that's going to look like in like 10 years? Like, are able-bodied people that don't have disabilities going to be augmenting their bodies with like bionics essentially? Evan or Connor, sorry, go ahead.
Yeah, I definitely, so I do believe, yes, that like this is, I believe that it's a pretty long timetable to go from like humans today to the future human telepathic communication stuff that we talk about like with Neuralink. But I do believe that the general principle is accurate and valid, that minimally invasive technologies like what we're working on will soon become elective implants, right? It sounds wild, but if you think about cosmetic plastic surgery today and the implants that are received in that setting and facelifts and liposuction and injections and all of that, people are lining up out the door to receive all of these passive kind of implants, fillers, and things. Soon we'll be implanting people with active electronics that actually give some functional benefit or net value to the person in the real world. And so I do believe that like we will be interacting with the world around us in a wireless way. I do not believe that we're going to be telepathically communicating and like doing some of those crazy things in the future. And if anyone here has seen Severance, you can see how scary that future might be. It's also crazy that like we only talk about the positive things that could happen, like we can communicate telepathically really fast, but then leave out the severance type things that are more scary. So if you're going to talk about one, you have to talk about both.
Just want to say that I thought that your point about giving people agency over the data that they generate is a really, really good one. We did say that we wouldn't get into wish casting, but I do think that there is also a really cool potential for, and we talked about this a little bit beforehand, but in the future, ultimately, Connor, what you're building is an interface onto technology such that you can remain in control of it. And, Weave is building Isaac, and Isaac will ship with a companion app so that you can control it in addition to talking to it. But ultimately, these are just abstractions. These are just interfaces, and there's no reason that there couldn't be an interface that looks like a combination of our product and yours in the future at some point, which is super cool.
Absolutely. I mean, you can imagine that you have these humanoid type robots deployed at home, and you need some high bandwidth interface to be able to task it and control it, especially if it's hard for you to use your hands or something like that, and you don't want to constantly be screaming at your robot to tell it what to do, that you could have these more nuanced ways of communicating with it, utilizing sensors, both wearable and implantable.
That's nuts. Yeah. My last question here to wrap this up is how long is it until your guys' products are going to be in someone's hands? I know you have a roadmap. I think we've talked a little bit, Evan, about yours, but like, are we looking at it this year for sure? And I know for sure is hard to answer, but what do you think?
Yeah, so we're implanting in humans for the first time again this year, actually out in Australia, go figure, and maybe some other places. But yeah, so you'll see our technology deployed. It'll be a relatively small cohort of individuals. It's not like everybody's going to have this device. But then the following year, we'll do another much larger clinical trial in the United States, and then hopefully allow that to scale really quickly out to the general population that needs this technology.
I have a real quick question on that. Are you having any issues trying to deploy in the U.S. versus other countries? Like a lot of people will go to another country to get a service because of regulations here. Is that an issue?
The regulation here sucks. I mean, it slows down all innovation. It's really, really disappointing. So the reason we're going to Australia is because there's way less regulatory red tape to go through. They actually give you like a fantastic tax rebate if you do this R&D there and set up shop. So you can just move faster. You spend way less money. The people are just as forward-thinking and incredible. And then the FDA accepts that data. We shouldn't have to go out of the United States to go generate this data. We should be doing it in our own backyard. And it's incredibly unfortunate that we're not able to. But I'm optimistic that we're moving in a direction where it's going to be slow. Nothing fast happens, especially within the FDA and technologies like this. But I do believe that we're moving in a direction of less red tape, but not nearly fast enough.
Yeah.
I do think it's also a really great thing just to tip the hat again to our organizers too. Like freedom to innovate is such an important thing to reinforce, and it's going to be so central to technological leadership in the 21st century. The idea that you're slowed down as you simplify a life-changing technology is crazy. Yeah, we, as I said, are intending to ship to our first customers this year, and indeed people will hear from us even before then. And I think it's kind of an emerging theme of this talk that, getting to market sooner with a safe, quality product that solves real people's problems is just good business. So you can trust us that we want to get to people ASAP.
Great. Well, that's really about it. Do we have any questions in the audience of anyone who's interested? Yeah, Jack.
Roughly, what will your manufacturing mixes be between in-house and third party?
My mix.
Yeah, yeah.
What's interesting is that the portion of in-house has actually only increased over time. Again, keeping with like the practical bent, we wanted to order as many parts off the shelf as possible. But we've actually found that doing things more ourselves and actually bringing more of our supply chain closer to us is the way to move faster. So as an operating principle, we're going to move as quickly as we can, as durably as we can, and resiliently as we can. I am pleasantly surprised at how much that has actually meant. We onshore and friendshore the components that we build with.
Got it. All right. Thank you, guys.
First of all, I want to thank you all for your innovation and the things that you're bringing to the world. I appreciate it. I've been a nurse for 33 years, and one of the things that I've found is that when new technologies come out, there's a lot of resistance from people. And with this type of technology that y'all are coming up with, I find with people that I know already, there's a lot of resistance around it, and there's a lack of education and information. How have y'all built education for the public, for the information, so that we decrease the fear dynamic around this? There's a lot of fear around AI in the hospital systems and things being taken over, and like y'all was saying, jobs being deleted and stuff. What are y'all doing to inform the general public around what y'all doing? I'd really love to know that. Thank you.
Yeah, absolutely. It's, especially in the healthcare field, it's really hard to deploy. It's really hard to deploy technologies that don't currently exist that cause things to work in a radically different way, because the health system already makes a lot of money and is incredibly complicated. So if you try to throw a wrench into it and do something differently, there's a lot of pushback, regardless of how well-intended you are or how good the technology is. And so we're still pretty early in our journey and are focusing on the tech development and all of that. But our thesis kind of on how to do this is that results speak louder than anything else. And so if you can get truly groundbreaking, incredible results in your clinical trials and harness those results and the real stories of the patients that participate in those, and then utilize those to talk about your technology and what you're actually doing, rather than speculating about what you might do, 100 years from now when we're all long gone. That's kind of how we hope to do it. And same with getting payers to pay for something. If you show payers incredible, groundbreaking results of somebody actually having like their limb back, whereas they don't today, then that can help get payers on board for actually paying for your technologies and allow patients to be more excited about signing up to receive something like this and participating in clinical trials and elsewhere.
I think that in our case, the answer begins with simplicity and clarity. Again, I think that you need to be extremely forthright with people about what specific problems you actually want to solve. I think that one of the ways that people can rightfully grow concerned is when they frankly have no idea what your technology is actually supposed to do or not. And I think that that's one of the reasons why at Weave, we're trying not to boil the ocean, not only so that we can get to market sooner, but also because it's the way to make what we're building clearly intelligible. And I think that that'll also be complemented by the way that we want to make sure that Isaac, our product, only ever acts in ways that you can clearly understand and control too. So the actual user experience of it, I would add. But above all, I think it comes down to being crystal clear and repeating it all the time.
Yeah, the question is, how do you choose the name Isaac? I'm also wondering.
Yeah, we chose the name Isaac as an homage to Isaac Asimov, the science fiction writer who also coined the 3 laws of robotics and also wrote the book that inspired the movie of the same name, I, Robot. But he, theorized like ways that this can go better and worse, and it just felt like a cool way to kind of pay tribute to somebody who also kind of cared about building the future that you actually want.
It's awesome.
Question for Connor. I know you spoke about accessibility being a major component of the design. Can you speak about some of the signal processing challenges that you face with, I guess, like an intramuscular approach versus in brain?
Yeah, so without getting too, well, I'm not smart enough to get too technical, so I can just speak superficial to what I know. But so EMG, electromyography signals from muscles are very different than neural signals coming from your brain or spinal cord or nerves in the way that they look and their amplitude. So on one hand, muscle signals are 1,000 times larger in amplitude than neural signals like from your brain. And so bigger signal equals easier to work with and decode and do things with, because it's like somebody talking louder. You can hear them better and know what they're saying better than if they're whispering, right? But on the other hand, EMG signals are incredibly chaotic and stochastic. And so it can be really hard to find patterns within these really chaotic signals, whereas with neural signals, ultimately with brain-computer interface, what they do is they turn it into, they try to find a single individual neuron, and then they determine, is it firing or is it not? So it's binary, 1 or 0. 1, it's firing, 0, it's not. And then you amplify that by millions of different neurons, and you get a whole bunch of 1s and 0s that you can then use to tell what the person's doing. Like if they're closing their fist, it's 1 0 1 1 1 1 0 1, whatever it is, right? And so it's pretty straightforward in that sense. It's really hard to detect the signal in the brain, but once you do, if you can do it in a reliable way, it's actually quite easy to use it and pretty easy to transfer all of that data. Whereas with us, it's the exact opposite. It's really easy to detect our signals, but quite hard to utilize those signals. And the reason we go implantable is because when you have surface sensors, you have all these confounding factors of the sensors moving around, or sweat or dirt or hair or whatever it is. And every time you wake up and put the sensors on, the signals change, which means that they're really hard to utilize artificial intelligence to decode them when the signals are constantly changing. You can't find patterns in something by definition that is constantly changing. So when you implant sensors, both for brain and out in the periphery, you now solidify where those sensors are. And so the signals are still complicated, but they're static, meaning they're the same every morning when you wake up or every night or whatever it is, regardless of what activity you're doing, because you're just right there with these implanted fixed electrodes. And did that answer your question at all? Cool.
Cool. We got to wrap up. We got one more panel. Thanks everyone for
Thank you guys very much.